Welcome to Study Loop.
Okay, so this question is from physics where we have there is a gun over here. So this is the gun. An electron is being moving with a velocity v from the gun at a distance. This is a gun is at a distance d from a metal plate. Now this electron is released from here with a moving forward with a velocity v or a kinetic energy k. So if we apply a magnetic field, by applying a magnetic field, we can deviate the way of electron and can stop the collision with the metal. Now we need to find the relations to stop this with the magnetic field. First of all, the direction. The direction. We know that magnetic field, the force on the electron by the magnetic field is given by Q V cross B. That means if we that means the force should be perpendicular to the force velocity of electron and magnetic field B. All should be perpendicular to each other. That is mutual. Suppose if I consider we know the direction of V. This is the direction of V of electron. Suppose if I want to deviate this upside, so a force should be on upside. Thus, the magnetic field, the direction of magnetic field will be somewhere this way. That is going inside the. That is going inside the magnetic field will be going inside the plate. For consider magnetic field lines are going inside the plate. So the direction of magnetic field line should be going inside this screen, inside this plate. Now, uh, now to solve this question, the force on the electron by the magnetic field will be, say, if I represent E as a charge on electron, it will be E V B, where V is the velocity of electron and B is the magnetic field. So this is the force on the electron. Now, moving forward, the acceleration of electron. Since this is moving in a circular path, this will move in a circular path, so we can consider centrifugal force. So the acceleration of electron in magnitude would be given by v square by r, where r is the radius, where r is the radius. Now, applying Newton's second law, that is balancing the force on the electron. So, balancing the force on the electron, so EVB is should be equal to mv square by r. That is ma, where m is the mass of an electron. So this m is the mass of electron and v is the velocity. So solving this, we got the value of R to be R is equals to mass of electron V upon charge of electron into B. So we got this the value of radius. So we got the value of radius to be MEV by EV. Now, we in question it is given that the electron is moving with a kinetic energy K. So we know that the kinetic energy K is given by half me v square. This is mass of electron and v is the velocity of electron. So from here we find that v is equals to root of 2k upon me. So where we found the velocity, we have the radius. Now we're substituting the value of v in the radius. So our radius changes to r is equals to me, the mass of electron, upon eb. into root of 2k by me. That is, radius changes to root of 2me k upon e square b square. Now, in order to avoid the collision, this radius, in order to avoid the collision, the radius, the radius should be greater than or equal to the d. The radius should be greater than or equal to d. D is the length between the gun and the wall. So the radius r should be less than equal to d. That is, d should be greater than equal to r. Then only we can avoid the collision. So that means root of 2 m e k upon e square b square should be less than equal to d. Now taking b2 at that side, so b should be greater than equal to root 2 me k upon e square d square. Hence, proof. This is what we required to prove. And the direction of magnetic, for the second part, it is asked that what is the direction of magnetic field. So direction of magnetic field will be going perpendicular to velocity, uh, perpendicular to velocity, going inside the plane. So going inside the, so direction of magnetic field will be going inside the plane. Direction will be going inside the plane.